All right, so writing inequalities. First off, I want to kind of refresh us on kind of just what an inequality is. I mean, it gives us a range of solutions. It gives a solution set where our solution is not one particular number. It's a range of numbers that would satisfy our inequality. So that's how it's different than an equation. And again, our inequality signs are greater than, okay, less than, greater than or equal to, or less than or equal to. So the difference is here, the less than or equal to, the line underneath, means that it could be equal to that value that we're comparing our variable to. So reminder graphing, open circle is when it is not equal or equal to, and then it's a closed circle when it is. So on just kind of simple problems like this, where there's no nothing to solve for, just kind of expressing the situation with using inequality. So to ride an amusement park ride, you must be 52 inches tall or taller. So I'm going to say h is my variable, which is going to be our height. Okay, and I'm saying, okay, h compared to 52. Okay, I'm trying to think what inequality sign would go in here to signify or to represent that you must be 52 inches tall or taller. So first off, to ride the amusement park ride, I know that if I was 60 inches tall, that I would be able to ride this. So I know that's going to be greater. So again, greater than, if you can think of the alligator, if you're going to think back to elementary days when you were first kind of presented inequalities, but just kind of reading it left to right. This is saying h this is the greater than sign, is greater than 52. But always think, okay, when you get to this point, this be equal to? Can my height be equal to 52 inches and then I be allowed to ride the amusement park ride? In this one, since it's 52 inches tall or taller, yes. So I would put a line underneath to signify that this is h is greater than or equal to 52. Then graphing this, again, just a reminder here, so I had 52. Here I could have 53, 54. Other side of this would be 51. Okay, but my graph would be a closed point, and with my arrow going to the right, because all the values to the right of 52 that are greater than 52 would satisfy my inequality. So B, then, restaurant can hold at most 45 people. So we'll say P represents the number of people. So P represents the number of people, and I'm going to say P, we're comparing that number to, or comparing that variable to 45. So if it's at most 45 people, I got to think, okay, how many people can be in that building? All right, so I can have, okay, at most 45. That means that I can be under that, so I can be less than. So P is less than 45 is one option, but also if it's at most 45, always again think, can it be equal to 45? In this case as well, it can be. Okay, if something along the lines of can hold fewer than 45 people, we would not be putting that line underneath. But since it's at most 45 people, that language says that we're okay with it being exactly 45. So again, this one would be, I put 45, I put 46, 47, so on, and then 44, 43 to the left. So my point would go on 45. It is again a closed point because it is or equal to. So that means that 45 is included in our possible solutions. And my arrow would be going to the left, which is where the smaller values are, the lesser values. So that is just a simple look at writing inequalities in which we don't have a one or two step inequality where we have to solve something. If we look at one of those, so looking at a one step here first, again, we have to make sure that we define our variables. That's always an important step. So looking at this problem, we have a bus holds at most 47 passengers. There are already 29 passengers. So already I can see, okay, picking out some language here. At most, that's something that sticks out to me. So look at, when you're reading this, look for language that kind of talks about limits and talking about, well, you can have more than this or less than this or greater than. So look for those words, as well as words that would kind of help you with what operations you're using. So at most 47 passengers, there are already 29 passengers seated on the bus. How many more passengers can be seated on the bus? So looking at what the question is asking me, it's asking for how many passengers can be seated on the bus. So that's what my variable is. That's what my unknown is. So P for the number of passengers that we can add to the bus. All right. So sometimes There's a number of different ways that we can go about writing inequality like this, but I think that something that helps students the most is make sure that, okay, that limit, that one that I underlined here, it goes with the limit, that at most. It is sometimes easiest for students to put that down first. So 47, we know that that's the limit. We can't, and again, by limit, I mean this is the number that we either have to be above or have to stay under. And again, could be or equal to. So this one, at most 47. So on the left side here, okay, that's where I'm going to be putting my expression that represents the 29 passengers on the bus and then more getting on. So I got to think about, okay, what would my sign be? Okay, if I'm at most 47. So however many passengers are on, okay, the bus, which is going to be represented by the left side of my inequality, it has to be less than. Oops, back that up. Less than. Okay, because at most, we just had one I actually like that, to where at most means that you have to be under that are 47, but it's also could be equal to. Oops, not what I wanted. So erasing this and writing our expression there. So if I have 29 passengers on the bus already. So I have 29, okay, and I'm thinking, okay, if more passengers, which is P, I'm using the variable P to represent that, are getting on, what would I be doing? What operation is that? If I have 29 on the bus and then more people getting on, okay, the operation that we would be using would be addition. So 29 plus P or P plus 29, either way, would be acceptable, is less than or equal to 47. So that's the expression of the inequality that would represent this situation. Then, like we've been working on, you'd solve the inequality to find P is less than or equal to this many passengers. Looking at a two-step. Okay, so two-step means that there's two operations acting on a variable. In this one, it says Carl went to the mall and bought a pair of headphones for $24. He also found a sale on his favorite basketball shorts for $8 each. If he bought only $80, brought only $80 to spend, what is his greatest number of shorts that he could buy? So in this, my variable would be the shorts. Okay, so I'm going to use S for the number. Let me use the number sign here. It's hard to write. So number of shorts that he is buying. So S represents the number of shorts. So again, rereading this, looking for things that give us clues about the operations and the limit. So he went to the mall, bought a pair of headphones for $24. So that's just one pair of headphones. So reading that part right there, that's a clue that that's my constant, which again, the constant is a number that we're adding and subtracting, and we're not multiplying or dividing it by, or multiplying or dividing that with our variable. So he found a sale on his favorite basketball shorts for $8 each. Each is a repetitive kind of word where we're doing this something over and over and over. So $8 plus $8 plus $8 plus $8. When again we have something repeating like that, that's a good sign that we're going to be multiplying 8 by then the number of shorts, which that's our variable. If he only brought $80 to spend, what's the greatest number of shorts he could buy? So again, our variable, the thing it's asked for, is the number of shorts. If I start out with a limit again, I have 80. And if you brought $80, okay, and imagine that you don't have some type of debit card, credit card. Carl doesn't have this. He just has straight cash. Okay, that's what he's going to be paying with. How much can he buy? And we're taking taxes and things of that nature out of this too. So if he brought $80, that means he can't spend more than $80. He has to spend less than $80. Okay, he could also spend exactly $80. So if he can spend exactly $80, we're going to put that or equal to. Again, if it said that he wanted to spend less than $80, we would not put the or equal to. This inequality is also saying that he can spend less than $80. Just because he has $80 doesn't mean he has to spend exactly $80. Okay, he could spend less than it, or he could spend equal to it. So the rest of our inequality here is, like we said, we had $8 for each, and then $24 for the one pair of headphones. So $8 each for the pair of shorts. Like I said, that's $8 plus $8 plus $8 for the number of shorts. But the more simpler way, and the way that we would write that with an algebraic expression, would be 8 multiplied by the number of shorts represents how much money he spent on shorts alone. Okay, then I have $24. Well, that's my constant. Again, that's the number that I'm not multiplying by the number of shorts, because he just bought one pair of headphones for $24. So now you got to think, okay, if he's trying to spend less than or equal to $80, and this is the left side represents him spending money, Okay, if he's spending money on shorts and he's spending money on headphones, what do we do with those two costs to figure out our total cost? Well, we would be adding them. So I add those two costs together, okay, and this would be my then inequality that represents the situation. That's where I'm saying $8 multiplied by the number of shorts plus the $24 that he spent on the one pair of headphones must be less than or equal to the $80 that he has to spend. So again, we would solve for S, okay, and to be able to see, okay, S is less than or equal to this number of shorts, so that we could then find what the and graph that is, or plot that on the number line to signify this is the acceptable range of shorts that he could buy. So that is kind of a glimpse into writing the inequalities. We're going to practice that in class and continue to get better with not only writing them, but also solving them. So if you have questions, please let me know. I'd be happy to help, and keep working hard.